Both of these, this one says, I'm going to give you the vertex and I'll give you another point on the graph, and I want you to figure out the scale factor and write me an equation. Isn't that what it asks? What does it say? Does it say write an equation? Yes? In vertex form. So it wants me to write this equation. Okay? And then this one says write it in vertex form and then graph it, doesn't it? Does it say graph it afterwards? 67 just says write it in vertex form. So both of these are just wanting it in vertex form, right? Is that right? Okay. So part of this is easy. Do you know what this part is on 60? We're going to say y equals, do you know what goes in the parenthesis? What should go in the parenthesis? X, and then what? Minus what? 1. Opposite value of the vertex. X value. Okay? How about outside? Plus 8. Same value on the outside. Got it? So that part was easy. This part is what makes it maybe hard, maybe not. Let's find out. Think about being at 1, 8 on a graph. 1, 1, 2, 3, 4, 5, 6, 7, 8. Everybody with me? And then I'm going to go to 3, what? 12. So think about this. How far over to the right did I go? This is 12. This is 8. How far over to the right did I go? 2. And I went up what? Does that match the parent graph? Ah, so this is just a what? 1. What if it didn't turn out that nice? Well, then I'd have to change the scale factor, right? Maybe we'll do one of those in a second. Okay, but this one really turned out nice. I'm done. That's it. Because I went over 2 and up what? 4, which matched this scale factor. Okay, that's all we're checking with this other point. By the way, could you give me another point on the graph? If it's 3, 12, what else has to be on the graph? Negative 1, what? 12. It has to be symmetrical, right? Okay, let's try this one. 2 ways to do this one, but I'll just show you the one way and then the other way we're going to learn later, and then you're going to say, oh, but that's okay. First of all, we can put this in vertex form because can we find the vertex of this? This was set 3.3. How do I find the vertex given the equation? What's the key little tiny formula for this that we learned yesterday? And I had you write it in your notes, and I circled it like 20 times on the board. Do you remember? What's the x-coordinate of the vertex? Make sure this is written in your notes. Yes. Yes, it's what b though? The x-coordinate of the vertex is equal to negative b over what? 2a. That's so important because that helps you find the x-coordinate. The y-coordinate, you plug that in and we'll find the y, right? That's what we're going to do on this one. So I'm first going to take negative b over 2a. Well, that's easy. Instead of 10, I write what? Negative 10, that's the b part, over 2a, 2 times negative 5. Don't forget to keep the sign of the a value, okay? All right, what does that give you? 10 over negative 10, right? Which is going to be a what? A 1. Everybody agree with that? That's going to be a 1, because a negative over a negative is a positive. 1 is the x-coordinate of the vertex. Okay, how do I find the y-coordinate of the vertex? Plug in what? 1, just plug it in. So I'm going to go negative 5, 1 squared, plus 10 times 1, plus 3. Okay, so now what? Well, what's 1 squared? 1. 1 times negative 5? Negative 5. Just doing the order of operations. 10 times 1? 10 plus 3. Negative 5 plus 10 is 5. 5 plus 3 is 8. So what is my vertex? 1, 8. Everybody agree with that? Say yes or no.
Yeah.
Okay. What is the leading coefficient? Negative 5. That's also the a value. That is always the a value. Okay, the leading coefficient. So now I have my equation. Y equals what? Negative 5, that's the a value. Parenthesis, what goes in the parenthesis? X minus what? 1, opposite value of the x. Notice that this is h, or this is negative h, this is h. It's always opposite value. And then we have squared plus what? 8. Notice this is plus k, and this is also plus what? K. So if this is a negative, this will be a negative. If this is a positive, this is a positive. Exactly the same. The x value is always opposite. Everybody with me on that? That's it. I'm done. Is that very hard? No. Watch. Here's a little trick. Everybody agree with that so far? What did I do? What did I do? I just grouped that and factored out a negative what? 5. Everybody, we've done that before, right? Okay, now watch. Why would I want that to be like that? It's a perfect square what? Trinomial. But if I add 1 on the inside of the parentheses, negative 5 times 1 would be what? Negative 5. That's what I've added so far to the equation is a negative 5. If I've added negative 5, I've got to add what on the outside? Add 5 on the outside. Because of that 1 times negative 5 is negative 5. Negative 5 plus 5 is still what? 0. I haven't changed the equation. Okay? Now watch. What's 3 plus 5? 8. X minus 1 squared, negative 5 in front. There's my equation. That's called completing the square. We'll do that later. But it's just kind of fun. I could do it right now if I wanted to. It's not that hard. Factor out the common factor. Then complete the square by saying, hey, what is going to make this a perfect square trinomial? Whatever the number in front is, multiply that to what you added in the inside, and do the opposite on the outside. Because I've subtracted 5, I've got to add 5. That gives me my 8, that gives me the same exact equation. And I didn't have to find the vertex. I didn't have to plug in a value. So there's 2 ways to do this really, but this is the way that you've been taught so far. Okay, opposite of b over 2a, plug it in. Solve for the y value of your vertex. Once you have the vertex, then just put the leading coefficient as your a value. Both ways work. One way really isn't any easier or harder than the other. But, okay? All right, you can stop that.